Okay, so we're back. Now we're going to talk briefly about retrieving parts of a vector. Okay, so let's even take this out here. Let's take both of them out. And let's say change them to gets. Alright, so we've got, what did I just do? yvec. Oh, that's what I've done. I've overridden something. Very tricky. Okay. You can probably watch this in slow-mo and see what I just did. Alright, xvec. That is happy. We're all happy with x. The yvec. We are happy with the yvec as well. Alright. When we do numbers like this, they actually come out, if we go type of y, we can just do y, they're coming through as integers. Alright. Okay, but to retrieve parts of it, so we can just go like this, 5. That gives us the 5th element, which is 7. The answer is 7. So the answer has one item, and it is 7. Okay, we could also do 5 and 6. Can we do this? No, we can't. Alright, the reason is because we've got to wrap the numbers that we're asking for inside this combined list. So that's giving us the 5th and 6th elements. Okay, and so it's only, it's saying 1 here. It's saying the first number is 7, the second number is 3. So that's it. It's just putting the ranking at the start of the line. That's a bit confusing. It's not giving us the answer 73. And we can see here yvec 7 and 3. There we go. They're the two numbers that we've got. What else could we do? What about -1, -2? What's happening there? If you look at it, it's 3, 5, 6, 7 and 3, 4, 5, 6, 7. So it's just taking out the second number. So it's saying, give me everything but take out that number. Okay. One more thing I might show you is we're going to override a value. So here, let me just do yvec 1. We're gonna yvec 1, which is 3. There we go. We're gonna say that specific element is gonna get the new number 7. And there we are. We've seen it's changed. And likewise, we can do for 5 and 6. We can also call that 7. So there they are there, 7 and 3. If we run that, they've both become 7 now. Okay, so that is like overriding parts of a vector. Okay, I think we can fit a bit more in this video. So that's that. Okay, one thing I should probably point out as well is that when we run a bit of code, you're just printing it out. In this case here, we're just printing it out to the console. But if we wanted to save that as an object, let's say new object, we've got to do that. So now it hasn't printed it, it's just printed what we did. So if we want to print it out, we've got to run that portion to see what we've just done, the result of what we just did. So that's a key concept. You know, printing to console and running code versus actually saving code as a new object, saving your changes as a new object. The key concept. All right. What else? I thought I'd also mention silent objects. Okay. So if you know pi for the circles and stuff like that, pi is 3.14. So that's an object that is existing in the background of R just by default. Okay, but what would happen if we did 5? Okay, so now when we type in pi, we get the value 5. We've got it up here, 5. But if we wanted to use that 3.14 in a calculation, we wouldn't be able to use pi anymore because we've overridden that value. But we haven't destroyed anything. We haven't done anything wrong. If we get rid of our object that we're using to override pi with, if we get rid of that, now pies back to its normal value. So it's just good to know that certain object names already have usages in R. And probably the biggest example of that is true. So true is a Boolean value, as is false. Okay, but we can also just do T and F. Okay, so we don't ever want to override. We don't ever want to do true equals 5, and I don't know if it's going to let us. Yeah, so very unhelpful error code, but it's saying it's a reserved object name, don't use it. All right, so that is that. Yeah, I'll make a new video. Let's do it.